Welcome, everyone, to Actual Education Office Hours. My name is Dr. Gold. This is a stream that helps you out with math homework, science homework. All sorts of fun stuff. We got a question up from Klufel. What's going on, brother? This looks like a fun... Oh, ooh, intervals, like increasing, decreasing. I love all this. This is fun. This is, calculus. Laz, what's up, Laz? Yeah, Jeff's so happy we're doing math. Laz says, how many times I got the full A instead of the A minus just by showing up to office hours? 100%. Yes. I will openly admit, I bump students based on how much did you show up. And I think most professors do. So if you want it, nothing annoys me more than at the end of the year, someone who I've never seen, who's never shown up to class, never asked a question, and they're asking me to bump them from like a B plus to an A minus or something. And I'm like, who are you again? You've never put in any extra effort. Like, why would I bump you? But I get it. There's no harm in asking. You know, squeaky wheel gets the grease or some shit. But whatever. You're describing me, and I mean that's cool, dude. If you're just introverted and you don't want to be a part of the class and stuff, totally cool. Just don't expect any favors. You're not. I mean, and this is like a metaphor for life. If you want to get favors in life, you have to demonstrate capital. And demonstrating capital, the best way to do that is to show up. Show up. Be heard. Show the professor you care. They'll help you out. Okay, let's do this. Here's the function, e to the cosine of x. So this looks like a chain rule, I think, Klufel, right? So f of x... You might be too introverted. Well, it's time to, get a little bit out of your shell, because I'm going to give you guys a little bit of a wake-up call. If you want to interact in society, you have to be a little bit extroverted. So, you can't lock yourself in your basement all the time. You got to go do shit. So, learn. The best way to learn is to do. E to the cosine of x. Okay, so I know what e to the x is, right? So, d dx of e to the x is just equal to e to the x. But then, let's say we have the derivative of e to the u. This is equal to e to the u du dx. This is the chain rule. Right? And so with the chain rule, this is going to become e to the cosine of x. Then times the derivative of cosine, which is going to be negative sine. Cool. And then, do I want to do the second derivative? I feel like I don't, because that's like a product rule. I just don't want to do it. But okay, I'll show another way we can do it. Okay, so this is f prime of x. We've done part A. Good job, guys. We did part A already. Nice, good job, Klufel. That's part A. Find the intervals where the graph is increasing and where f is decreasing. Can you explain this thought process in more detail? What part of this process do you want me to explain in more detail? How to take a derivative? I mean, this is a simple derivative rule. You just have to know. When the Twitch notifications are delayed. Oh, I'm sorry. Maybe they're getting too hyped for TwitchCon tomorrow. I think TwitchCon, technically, you can go pick up badges today, but I'm not there. What's up, River? How'd your biology go, River? Okay, so increasing is when f prime of x is positive, and then decreasing is when f prime of x is negative. You turned it in last night? W, dude. Turn in your homework, dude. It's the least but most powerful thing you can do for your grades. Oh, really? Do they? Oh, that's whack. Okay. Okay, so let's look at this function, f prime of x. So, I mean, you can do this like blindly just with math, but I like to analyze the parts of this and just see what happens. What's up, Omar? Good to see you, dude. Yeah, we had a lot of people this week on TikTok. I think I gained like 100 followers on TikTok just from live streaming. which, thanks for coming by, guys. Appreciate it. Helps with our metrics. I haven't taken as much time to make the little YouTube shorts that I do, or I guess TikTok shorts, but I will get to those soon. Calendar. Yeah, does it show the calendar? River, tell me if it does. I hope it does. Yeah, do those things work? I can't see them in my chat because I have the bot, like... Let me see. Actually, I can probably see if it shows up. Yes, it does show up. Fuck yeah, good. Love that. Good. Okay. I love when things work. Alright, so this is going to be... Let's put like a... Let's color code this. E to the cosine of x. And then we have times... negative sine of x.
Nice.
What are we learning, bro? Chacho sauce. We're learning calculus. Mainly, I think this is kind of like called like curve. Not curve fitting, sorry. Like graphing. Curve visualization or something. Thanks for the follow, Snoop Dogg, by the way. Triple X Snoop Dogg. And also, if you ever want to see the original question we're going through, you go to this website, click on live queue. This is what the queue is so far. There's only one question, so if you got a question and you want me to answer it, put it in now. But if you click on the username, you can see like what the question is that we're going over. Cool. All right. So, let's look at the derivative here. There's two parts to it, right? I have this e to the cosine of x. I want you guys to think about, in terms of like positive and negativeness, what can happen when you have e to the something. I cover all the calculuses, crewless, yeah. This is Calc 1, but I cover all of them. So, e to the something is kind of the same as, I don't know, let's say like 3 to the something, right? If you raise a positive number, which e is a positive number, it's just 2.718, to an exponent, that can only get you a positive number. What's wrong, Jeff? You don't like 3? What's wrong with 3? Exactly, yeah. E does not equal 3. Oh, it's close to 3. Yes, love justice for black people. You're correct. E to the cosine x is always positive. Let's show why it's positive. So for instance, if I plugged in like 3 to the 4th, right? This is just 3, a positive 3 just multiplying itself a bunch of times. I think this ends up being like 243 or something. If you try to put negative numbers in there, like let's say for instance you put like a -2. Some students think that this is somehow like -3 to the 2. It's not. Okay. The thing we learn about negative exponents is you can turn them into positive exponents as long as you flip like where it is. And this is called like taking the reciprocal. So this is really 1 over 3 squared, which is equal to 1 over 9, which is still positive. PDEs, not so much. PDEs are kind of hard. I don't really do PDEs. I can do regular DEs. If you got a regular differential equation, I can solve it. PDEs are a little bit much. So, again, if you have a positive number raised to whatever power, I don't give a shit what it is, it'll always be positive. So this is always positive. Cool? So, the only thing that determines whether the derivative is positive or negative is really this thing, right? Because a positive number times a positive number will equal a positive. And then a positive number times a negative number will equal a negative. So I really don't even care about this. I just care about this part. Okay? So, in order for it to be increasing, I need this to be positive, right? But this is negative something times sine of x. So that tells me that for increasing, which is f prime of x is positive, I need sine of x to be negative. Okay? Couple ways to do this. Wow, finger heart. Thank you, dude. 70 coins? Hell yeah, dude. That's 21 cents. Fuck yeah. We're eating good tonight, dude. I appreciate you. What is your username? Object? It's not showing on my name. It's showing on my feed what your name is. So I need sine of x to be negative. A couple ways to do this. You could think about the unit circle. Do some Navier-Stokes. Why don't you do a barrel roll, stranger? I don't want to do Navier-Stokes. That sucks. What's up, Maria? Tell me physics is going well. Tell me some good news, Maria, please. Okay, so in order for sine to be negative, we remember that, right? For some angle theta, that sine is equal to the opposite over hypotenuse. Wow, Maria says, one sec, because I helped Maria out a week ago or so. She says, it actually makes sense for once. Fuck yeah. And you're doing projectiles. Wow, that's super fun. Awesome. I'm going to treat myself to something nice with that 21 cents. I really am. Thank you, dude. Do you have a name you want me to call you? I can't see your username in TikTok. It's like, it's an emoji, apparently. Okay, so sine is opposite over hypotenuse. So when you look at the unit circle, if like you're going around like this, you need the opposite here to be negative in order for sine to be negative. And the opposite is negative over here. So for instance, when let's say like you're at this angle, theta, okay? In that case, the opposite is below the x-axis, so it's in negative y land, and that would be negative. And so that happens everywhere from here to here. We can say that sine of x is negative. And so that occurs from pi over 2, from pi, this is from pi to 2 pi. That's the angles. Okay, cool. And then we look at our domain, which is 0 to 2 pi. So yeah, so that means it's increasing for pi to 2 pi. Not inclusive, because at pi, the derivative is 0. Also 2 pi, it's equal to 0. Let me see what Maria says real quick. One sec. Hell yeah, those are fun. They actually make sense. It's because I was good at trig. Yes. You're going to cook on the test tomorrow? Fuck yeah. Thank you for your help. You've helped a lot. Aw. Love that, Maria. Thank you for coming by and telling us. If you ever have questions, you know where we are. Lol, the sound effects. Math grad from UGA. Cool. Brings you back to undergrad? Yeah, this is intro. You know what's funny, Kevin? Sometimes even like math grad students can't do this stuff because they're so far down their PhD that they've forgotten like the basics. I have a lot of students I work with sometimes at, you know, they're either doing like DiffyQ or they're doing linear algebra or something, and their TA can't even do the problems because their math TA is like so far down in like the algebraic topology land that they just forgot this stuff. They're like, I don't use it, so I don't need it. Use it or lose it. The last one? Yeah, I totally can. Is it the math with friends? Is it question number 9 or the math with friends? Favorite class was graph theory. I love when math starts coming up with classes that sound simple, but they're just absolutely a nightmare. Like the class will be like number theory. I'm like, cool, yeah, like 1 + 1 is 2, right? But then it's not. It's a lot harder. Cool. Math with friends. Nice. Yes. I'll put that up for here for you. Engineering is greater than math or physics. I mean, in terms of salary, yes. But okay. Back to the question. So increasing when sine of x is negative, that's from pi to 2 pi. What's up, Roman? And then that means it's decreasing when it's not increasing. So that would be the other like part. That's when sine is positive, right? So for decreasing, f prime of x is negative, so sine of x has to be positive. This is calculus, yes. Someone in my chat's asking about stochastic processes. I honestly don't know a lot about stochastic processes. Is that like Brownian motion and stuff? You really enjoyed probability. That's great, though. I love probability. I love stats. All that stuff is great. Best way to get involved is probably, to get started is, I think, textbooks these days. Or go find someone who has like fun videos on it, maybe. Or better yet, find someone who's doing research with it and then see if you can help them. Okay, sine has to be positive. Sine is positive in these quadrants here, Klufel. And so that's going to be from 0 to pi. Nice. If you submit it, Roman, I'll try it. Okay, cool. So now we've done part B. So here's the last part here, they say. Find the coordinates of any local minimum and any local maximum points on the graph. Excellent. So Local mins and local maxes occur at critical points, and critical points are where the derivative is equal to 0. So we're looking at, like, where does f prime of x equal to 0, okay? Well, let's remember, f prime of x was equal to this, right? And this is always positive. So I need this to be equal to 0. And sine of x is equal to 0 at 0 and 2 pi. Cool. So, and that's within our bounds, right? 0 to 2 pi, so that's great. So I can say, okay, cool. X equals 0 and x equals 2 pi. If they want the points, right, then we need to plug them into what the original function was. Because remember, f of x, the original function, was equal to e to the cosine of x. So if we plug 0 into here, you get e to the 0. Oh, also sine of x is equal to 0 at pi. Thank you, Jeff. No, totally. Sorry, it's equal to 0, pi, and 2 pi. Can you explain the pi and 2 pi increasing part? Okay, yeah, let me do that. Sorry. Okay. So, function is increasing when derivative is positive, okay? This is the derivative. The derivative has two parts. It has this e to the cosine x part, which is then multiplying by a negative sign part. This e to the cosine x is always positive. So, in order for this whole thing to be positive, I don't really care what this does, because this is always going to be positive. But I care what this does. So in order for this to be positive, I need this whole thing to be positive. But this is negative sine of x, which means I need sine of x, particularly, to be negative. Because then a negative times a negative gets me a positive. So this is the main thing. Once you get to here, okay. Now, where is sine negative? One way to do it is to remember the unit circle. That's a good way to do it. Another way is you could remember what the graph of sine of x looks like. It's kind of useful to know, right? So sine of x ends up looking like this, right? Where this is 0, this is pi, and then this is 2 pi, okay? And this is sine of x. So sine of x is negative between pi and 2 pi. You could also see that on the unit circle, okay? Because sine refers to the opposite, which is kind of like the y-coordinate as you go around in the unit circle. And the y-coordinate is negative once you've hit pi. Well, right after you hit pi. At pi, it's equal to 0. But then it's negative here all the way until you hit 2 pi. Okay, so these values of sine of x get you negatives. What's up, Sib? Does that make sense? And then in the other case, right, so if it's increasing for when sine's negative, by symmetry, it's decreasing when sine is positive. And that occurs here between 0 and pi. You can also see that in a graph of sine, right? Graph of sine is positive from 0 to pi. So both of those are great. Okay. So yeah, and then when you're trying to figure out where sine is equal to 0, because that's when the derivative would be equal to 0, right? Because as long as this thing is 0, the whole thing is 0. And 0 to pi, yes, exactly. Yeah, 0 to pi, but not including 0, not including pi. Stranger giving me rage bait. What are you doing, Stranger? 2 out of 10 rage bait. Okay. So again, looking at this, sine is 0 at 0. It's also 0 at pi. And then it's also 0 again at 2 pi. You can also, again, see that on the graph here, if you remember how sine works. It's 0 at 0, it's 0 at pi, and it's 0 at 2 pi. So those are my solutions for x. I realize I probably kind of wrote this kind of badly, honestly. Ugh. Sine of x sine of x equals 0 when x equals those things. It is Calc 1, bing bong. So it equals 0 when x equals 0 pi or 2 pi. Okay. Bing bong. Is that from that one meme of that guy like going around Philly and like interviewing people? He's like, Joe Biden, what's up? I love that guy. Yo, I got an exam tomorrow. Can you teach me about graphing derivatives? Yes. Can you send me a screenshot, Bing Bong? Send me a screenshot. That's what students are doing. If you send me a screenshot, I'll go over the question. So here are the x values. We're gonna plug it back in to here to get the y values. So that's gonna be e to the 0, e to the cosine of 0, e to the cosine of pi, e to the cosine of 2 pi. E to the cosine is 0, so cosine of 0 is 1. So this is just going to be y equals 1. Cosine of pi is equal to negative 1. So e to the negative 1. Or sorry, I fucked this up. My bad. Sorry. Cosine of 0 is 1. So this is y is equal to e to the 1. This one is y is equal to e to the minus 1. And then this is again y is equal to e to the 1. So your points are 0, comma e, 0, comma 1 over e, and 0, comma e. Again, or sorry, I'm messing up. Sorry. This is 0 e, pi, comma e, 2 pi, comma e. The derivative is equal to 0, but the x values are different things. Okay, there we go. Those are critical points. These are big, so I'm just gonna say these are maxes. I'm gonna say this is a local max. I could be wrong. Technically, I would need to look at what the derivative is beforehand. I think that's true. Also, the question I don't think is asking... No, they do want to know the local max. Ah, fuck. Okay. Technically, we have to do it. Usually, I look at it, and I'm like, if the value is a big value, it's a max, and if it's a small value, it's a min. And that may be true. This isn't the proper way to do it, though, unfortunately. Here's like the more rigorous way your teacher probably wants. But we'll see if I'm right. So you can either figure out whether something's a max or min by looking at the second derivative, or you can look at what the value of the derivative is, like to the left and to the right. Okay? This is calculus. So, okay, f prime of x was equal to this. Right? Not on DMs, Bing Bong. There's a website. Do you see the website there? Actualofficehours.com. Just send it there. And I'll get to it. Maria, I'll do yours next because I saw yours directly, but everybody else, please use the queue. The queue is the best way for me to help you. Okay. This is where you got to do this. You got to make like a fun little table. So this is x, and then we're going to say like f prime of x. Oh, it does? Yeah, they both work. They both work. Yeah, I'll fix that. Go to any website. You'll get there eventually. I own all the domains. Okay. So we got 0. So when x is equal to 0, the derivative of the function is equal to 0. That's cool. So 0 means like flat, right? And then we also have, we're going to figure out where it is at pi, which is also flat. And then we also got to look at where it is when it's at 2 pi. Okay, which is here. Which is also flat. Okay. So now my job is to see what the value of the derivative is at values of x that are in between our critical points. So for instance, I could look at pi over 2. That's in between 0 and pi, right? And let's look at what our function becomes. So again, I don't care about this. This is always positive. Okay. But let's think about the sine of pi over 2. Oh, that doesn't really help me though. Sine of pi over... No, it does. Sine of pi over 2 is 1. And so that's negative 1. So that means that this is negative. So watch how I did that. So, right? Negative sine of pi over 2. That's equal to negative 1. So the derivative is negative. And if the derivative is negative, it's sloped down. Let's find something in between here. I could do 3 pi over 2, for instance, right? Negative sine of 3 pi over 2. Well, sine of 3 pi over 2 is negative 1 times negative 1. That's equal to positive 1. Positive slope means it goes up. All right. And then I could pick something back here. We could say negative pi over 2. Cosine of negative pi over 2 is negative 1 times negative 1 is positive 1. So that's up. And then here I could do the same thing as pi over 2. This would be, what, this 5 pi over 2? No, yeah. I like looking like flat and down. Yeah. And then, so, pi over 2 was down. Okay, so here's a cool thing. So now looking at my function, right? These are like the x values. I can see that the function increases, it goes flat, then it decreases. Then it's flat, and it increases, then it's flat, and then it decreases. So that means that this is a max, or a local max. This is also a local max. You could do the second derivative test too. Yeah, it's just I didn't want to do the product rule. And then this is a local min. So I was right. Min, max, max. Second derivative is ugly. Yeah, cool. All right, clueful. Does that all make sense to you? Everything we did here? Is that gravy wavy? Econ, maybe. I haven't really tutored much econ. Wow, how did the queue already get up to 10 questions? You guys like fucking slammed my question thing. Yeah, it works. Okay, awesome. Good job, Clueful. Nice. All right, new post. Clueful. So yeah, again, I'll post the solutions here in Discord. So there you go. And you go look at it. Sorry, it was probably me. Bing bong. Bing bong, yes sir. What is that fucking more Italian brain rot? God damn it. I use cappuccino. Ballerina cappuccina. Yeah, I used her in my one of my classes I taught at UCLA. I put it as like a practice question. I was like, ballerina cappuccino like spins around. Like, what's the ratio of that? Like, I don't know. It was funny. All right. Let's look at the queue. So yeah, if I pull up the queue there, bing bong, bro. Why did you submit so many things, dog? Are you okay? Are they all the same thing? Or did you just submit all your homework? Oh, you submitted the same thing many times. Okay, I got you. That's okay. Bless you. Bless you, child. Yeah, they're all 1 second apart. Except for the last one. Okay. Nice. Okay, so that was... Cluefuls. Cluefuls is done. Nice. Maria, let me help you out with yours. And then I'll go back to Odin Root. Odin Root's the next one. Okay, fire. Yeah, okay, cool. Let's do this. All right. A circus acrobat. Physics. Uh-oh, Jeff. Disqualified. Jeff gets so upset when we do physics. I'm going to go shower. I'll be back, my friends. Okay, great. Yeah, go get clean our stuff. And you're following us? Thank you so much, dude. Wow. You got to follow? Love that. This is really math in disguise. It is. It's math with style. A cannon's positioned 8 meters above a safety net at a velocity of 18 meters, 65 degrees above the horizontal. What is her maximum height? Okay. So we got this. And then we got the acrobat getting fired out at 65 degrees. That's actually quite tall, honestly, 65 degrees. So this is 18 meters per second. 65 degrees. Before I even start, Maria, I'm going to write out the components of this. It just helps me out, right? We're going to need it eventually. So I'm going to say that V naught x is equal to 18 cosine of 65 degrees. And then V naught y is equal to 18 sine of 65 degrees. And we understand where that comes from, I'm pretty sure, yeah. All right, cool. And then she's located 8 meters above. Oh, does she? All right, cool, Dark M. Yeah. It'll be on YouTube. I don't know if the VOD will show up on TikTok, but that same link you used to submit the question, there's a link there. Make sure to just like subscribe to our YouTube or Twitch. It should show up there. Okay. Max height. So max height occurs Vy is equal to 0. Cool. So I'm going to use this question. Bits. Yeah, you can send bits on Twitch, I think. You can also send super chats in YouTube if you want. So Vy squared is equal to V naught Y squared plus 2A, and then we can say like delta Y. I like using this equation, Maria, yeah? Bits, bobs, whatever. Dude, it's all weird shit. Oh, A levels. Yeah, this is definitely A levels. Okay, cool. So this is 0. So 0 is equal to, and then V naught Y is going to be 18 squared sine squared 65 degrees. Acceleration is going to be negative 9.8 because that's just gravity. And then delta Y, so that's going to be Y final minus Y initial, but Y initial is 8. And so there you go. That's how that's the stuff. So then, you know, just do some calculator math. So no. A is always negative. So for things in free fall, Maria, A refers to the acceleration of the object, and if it's in the air, the acceleration is always negative 9.8 because that's the acceleration due to gravity. Gravity always points down. The only time that this will be positive is if I'm measuring my position, for instance, like backwards. Like if I'm measuring positive Y like down here. It happens sometimes, but not very often. As long as you call this Y equals 0 and everything above is positive, then the acceleration due to gravity is negative. But if for some wacky reason you call this like Y equals 0 and you call this like positive Y, then acceleration would be positive. Yeah, great. EO has it. Yeah, if you resolve upwards, gravity is always negative. Can I do quantum physics? Oh, you can try. You can try to ask. My PhD's in physics, but I failed quantum in grad school. Yeah. And by fail, I got a B. I got a B minus. B minuses are failing in grad school. It sucks. All right. So 18 squared. And then that's going to be... Oh, not K. What grade do people learn this? This is high school, I think. Maria, you're in high school, yeah? All right. Sine squared of 65. Yeah, she's a senior in high school. And then that's minus... Okay, whatever. Well, let's get that number first. So that's that. Then we're going to move that to the left side. So you have negative 266.13 is equal to negative 19.6 YF minus 8. So then divide this over and then just add 8, right? So that's technically negative. So dividing by negative just makes it positive anyways. I don't really care, right? So 19.6. And then we add 8 to it. Cool. So the maximum height is 21 meters. Okay. So Y final is equal to 21.6. 21.6 meters. PDEs for you, brother, dude. Wow. Is the graphing calculator on your screen free? Yeah, I don't pay for it. I think it's like questionably legal. Because I had to like pull my ROM. But yeah, you can always DM me if you want. It only works on Windows. I haven't found emulators that work well on Mac or on like phones really. Andre says, I got a B in math, A level. Do you think I would be okay doing civil engineering at uni? No, yeah, civil engineering, totally. I mean, you should always like try to improve your math a little bit, but a B is solid. B's get degrees, man.
Nice.
So yeah, unfortunately, Chaser, I don't really know much about PDEs. I know DiffyQ, but PDEs I don't. If you want to get help though with more advanced math, Halo theme's coming in. There's another really awesome streamer that we work with. His name is Zach, E to the 2I Pi, and he's streaming Saturday morning, and you can ask him anything. He has a PhD in math. I have a PhD in physics, but if you ask him, he can probably help you out. If you want to figure out when that is, so if you ever, there's that website down there, right? Actualofficehours.com. If you go here to our streaming schedule.
Someone got my baby voice. Thank you, Cliffle. I can definitely do related rates. There is a calendar, and then on the calendar here you can see like when we stream and when other people stream. And Zach will be on Saturday morning, and then here's the link for him. So go to that website, you'll see what's up, and you can go get help. All right, back to this question. Maria says the only math I was good at was geometry, only because I had a good teacher. Yeah, I had a great teacher for geometry. Yeah, he really probably changed my life.
Yeah, you totally chase a robot. Yeah, just go find it. You got it. Okay, how long in the air? How long is she in the air before she lands in the net? Oh, the net is down here then, right? Okay, so this was all like part A. Yeah. So then like she goes up, and then she falls down. Okay. So to figure out how long she's in the air, that's something with time, right? So I need to use my kinematics equation for time, which is that y is equal to, so y final, sorry, is equal to y initial, or y naught. I switch up my initials and what knots all the time. Okay. Plus v initial t plus 1/2 at squared. Okay. Well, this is easy. Her final height is 0. Her initial height is 8. Her initial velocity, this is key thing, only in the y direction, because we're talking about y direction movement. That's going to be the 18 sine of 65. 18 sine of 65. Cool. And then that's all times t. And then this becomes plus 1/2. A is negative 9.8. T squared. Cool. All right. All that's left is to solve. So actually, next we got to do a little bit more work here. Sorry. So, oh, is this going to... Oh, this is a quadratic.
Surprise, motherfucker.
Fuck. Okay, fine. Wait, I need my calculator. I don't know what the sine of 65 degrees is. I don't think anyone really knows what the sine of 65 degrees is. Also, okay, good, we're in degree mode. I was just like checking for a second that we didn't like wreck ourselves here. 8 sine of 65 is 7.25. Okay, so you have... let me move this like over here. Let me move this over here on the other side. So 1/2 times negative 9.8 is negative 4.9. But then I'm going to move this over. So I get 4.9 t squared. Then I'm going to move this over. That's minus 7.25 t minus 8 is equal to 0. Okay. This is not easily solvable by just using algebra. You have to use the quadratic formula. Unfortunately. Which I could do. I could also just graph it. I'm going to show you the easy way to do it with graphing. Because I just don't want to do the quadratic formula right now. So the way to do it, you just go to y equals here. And you do 4.9 x squared. If you want me to do the quadratic equation, Maria, you can ask me to, and I'll do it. But I think this is like a cooler way to do it. Because once you have your thing here, you just hit trace. And it should graph it for us. There we go. Bingo. Look at that. No quadratic? Yeah, fuck that.
No.
Okay, so then all you do, if you want to figure out like where it hits 0, you go like second calc, 0. And then left bound is like the leftmost you think it's going to be. Sorry, let me put it here. And this is the rightmost you think it's going to be. And then you hit enter. And cool. You get time is equal to 2.22. Cool. I agree with that. So t is equal to 2.22. There's another solution that's negative, but that doesn't make any sense. Because we can't go backwards in time. Okay. What is her horizontal range when she hits the net? This is great. I like this. So horizontal range. So that's equal to like delta x. So you can say, okay, well, x final is equal to x initial plus v naught x times t plus 1/2 at squared. Now, in the x direction, so when this trapeze artist is moving like this, their velocity in the x direction does not change. Their velocity in the y direction does, right? Because they're going up, then they're not going anywhere, and then they're going down.
Oh, no.
In the x direction, it's always moving to the right. That's like the composite movement. So there's no acceleration in the x direction because there's no forces in the x direction. And x initial is also 0. And then we're solving for x final. Cool. So x final is equal to v naught x. So that was 18 cosine of 60. Or was it 18 or 8? Sorry. Oh, did I fuck up this whole time? I just said... I said 18, right? Wait, did I do that right? Yes, I think I did. Yeah, okay. I'm just making sure. I was like... Oh, no, I didn't do that right. God damn it. I put an 8 here. I'm sorry. One sec. I looked at that. I'm like... that. Okay, wait. 18. Stop. I messed up. When I calculated that 7.25, that was 8 sine of 65, not 18. Damn it. Also, why is my calculator not working? Excuse me? Hello? Okay, there we go. So 16.3. Oh. Trace it again. Okay. And then let's calculate the 0. Hey man, where do you get these practice questions? I want to, so these are from students. Students submit these to me live on the stream, and then I just go over them. So, if you just want to hang around, you can see what other people are learning, and that'll kind of help. Also, if you want to join our Discord, I post all the questions that I do there. And so you could see, like, you could try to do them yourself if you wanted to. And then the solution's there because I've already done it. Okay, sorry. So the time here is 3.76. Okay. So back down to here. X final is v naught x, 18 cosine 65 degrees, times the time. And that's the time it's in the air, which is the same time as this. 3.76. So we're just going to take that. 3.76. No, I love Casio watches. Don't get me wrong. I'm a big fan of Casio watches. But for calculators, TI is supreme. I'm sorry. It really is. I understand that Casio is a lot cheaper. Trust. Like, it is obscene how much you pay for a TI calculator, but it just works. Practice exams, just look up like AP Physics C, like free response practice tests. Yeah, AP Physics posts all their free response questions of their tests. Just keep doing those. Okay, cool. So that's 28.6 meters. D, what is her true speed? Her true speed? What the fuck is true speed? Just before she hits the net. Okay. So, V, like at the net, is going to be equal to the square root of Vx final squared plus Vy final squared. How do you send a screenshot? Just type in exclamation point submit, and it'll tell you the website. Or it's the website down there, actualofficehours.com. Okay, so the velocity in the x direction never changes. So that's just going to be 18 cosine of 65 degrees squared. And where this comes from, right, is that when this thing, like, hits the ground, like this is going to be, like, VF net, I guess. And it's going to have some VX final component and then some VY final component, Maria. And then what this formula is doing like the Pythagorean theorem to figure out what, like, the total final velocity is. Good. Nice. Okay, cool. All right. So it's that, and then you got to add in the final velocity in the y direction, which Vy final is equal to Vy initial plus At. So that's equal to 18 sine of 65 degrees minus 9.8 times the time, which is 3.76. Okay, so let's get numbers for that real quick. 18 sine of 65 minus 9.8 times 3.76. So that's negative 20.53. So negative 20.53 squared. Okay, cool. So square that. Add it to 18 cosine of 65 squared. Square root all that. And then you get your final speed of 21.9 meters per second. Nice. Getting some good views, I see. Yeah, what's up, Haji? Well done. Yeah, we've been doing well on YouTube recently. I'm happy. You're welcome. So, Maria, I'm going to post this in the Discord for you. I post everything in this like channel. So I'm gonna create this. I'm gonna say like new post. Feel free to join our Discord again if you want to see everything that happens. And then I'm just gonna drop that for you. Office hours. Cool. You're very welcome. Nice. Cool.
Oh yeah.
I definitely need to brush up on algebra and then try again. Yeah. So stay tuned. I'm gonna come up. I have like a remedial like math course that I built because when I was teaching physics at UCLA, I noticed a lot of students had various levels of math they understood. I'm talking like basic math, like exponents, fractions, all that stuff. Like the core stuff you need to do in physics requires some core stuff in math that you need to know. And when I was teaching the course, the first week of my lectures was just core math stuff. I was like, okay, I need to make sure you guys know exponents. I need to make sure you guys know vectors, some basic trig. And I'm putting that together as its own like standalone thing that you guys can access for free and just go through. So for those people that are like trying to get like back into math, or I don't know, maybe you like brain rotted too hard over the summer. Yeah, join our Discord so you'll get the announcement for it. And I'll drop it for you. Yeah, you have to take applied calc. Yeah, then yeah, you need to know this basic math stuff for calc. Okay, cool. Let's go check the queue. H, you're next. Bing Bong submitted all of these things. 4, 5, 6, 7, 8. Let me just clear some of yours, Bing Bong, just so people don't get scared that the queue is so big. So I think I'm gonna clear 5. And then I'm gonna clear I can clear 5 again. Clear 5 again. And I can clear 5. Okay, there we go. Now it's fixed. All right, let's get use a Lagrange multiplier. Oh Jesus, Odin, what are you doing to hurt me here, dog? How do I connect to the Discord? So the website down there, actualofficehours.com, looks like this, and then there's a nice link here that says join our Discord. You can click here to join the Discord. You can also, if you want to watch this on Twitch, Twitch has a nicer horizontal format if you're on a desktop. You can we broadcast to Twitch, YouTube, and TikTok all at the same time. So whatever device you're on, if you're on vertical, TikTok and YouTube are still pretty great. But if you're on a desktop and you want like the full widescreen view, Twitch has that. So that's probably the better one for that. Dr. G, do you think it's a good time to do an exchange semester in the U.S.? Well, now we're asking like politics. I don't know. I think I understand why a lot of people don't really want to come to the United States right now. Because our visa situation is fucked.
Fuck!
But I think the U.S. is a great place, regardless of what's happening. So if you can, yeah. Just maybe make sure that you have all your visa stuff sorted out. Because the worst thing would be for you to get like kicked out. All right. Jeff, do you know how to do this? Do you know how to, bro, I have not used Lagrange multipliers in like 3 forevers. Georgia Tech's great. I think we have someone in our channel here that goes to UGA, which is I think like the rival school, like Go Dogs, Bulldogs, right? Who is Lagrange? He's a pretty cool guy. Any kinematics problems? We just did one, Omar. This was this whole thing. Not here. Sorry. This was a big kinematics problem we just did. This was all kinematics. Yeah, I'm gonna look up some resources. I gotta remember how this works. Okay, use a Lagrange multiplier to find the maximum and minimum values of that subject to the constraint. Okay. So, like, this is a function of two variables, right? But then I'm restricting x squared plus y squared equals 1. So this is cool. So I'm restricting this to a circle, right? This is also the equation of a circle of radius 1. Yeah, I could reduce this to one variable. I think I could, right? With the constraint. But they want me to use, like, Lagrange multipliers, though. If I'm a sophomore in high school doing pre-calc, do you think if I grind out pre-calc and calc on con that I could skip pre-calc and get into calc? Yeah, totally. Pre-calc is just a bunch of little tools you learn in order to be able to do calculus. So as long as you learn the tools, then you can do calculus. So if you do them on your own, then you're fine. Sorry, why is this a circle? I never heard of this till college. Well, x squared plus y squared is equal to 1 is the equation of a circle, right? So this is a pre-calc thing, right? So the equation of a circle is equal to, that's like x squared plus y squared is equal to r squared. So my constraint is x and y have to be on a circle. Okay. Derivative is that. Yeah, what's the hardest part of Calc 3? Probably like Green's theorem and Stokes' theorem, I think. Alright, I'm shamelessly going to use ChatGPT here because I don't remember how Lagrange multipliers work. So, I'm just going to learn it with you guys. Odin, you're starting to surpass like the knowledge I know. This is a little bit more intense math that I haven't done yet. Or I've done at some point, I just forget. Okay, you set g of x from the constraint. Okay, so they rearrange this to be x squared plus y squared minus 1 is equal to 0. Okay, so you set the constraint equal to 0. Okay, Ryan has this, right? He says gradient f equals lambda gradient g. And that's what I see here. Cool. So gradient g means you take the derivative of this with respect to x, and that's the x component. And then you take the derivative of this with respect to y, and that's the y component. So partial x of x squared plus y squared minus 1, that's equal to 2x. And so that's going to be in the x hat direction, right? And then partial y of x squared plus y squared minus 1, that's equal to 2y in the y hat component. And that's why they say grad g is 2x comma 2y. It's really a vector. They really should do this. It's a vector. And then grad f, okay, same thing. Derivative of this with respect to x is 2x minus 1. The derivative of this with respect to y is just 4y. Again, vector. And then what we say, for whatever reason, I don't understand this, but apparently grad f is equal to lambda grad g. Okay. So, you got to do that by components, right? So this part here, Odin, has to match up with this part. So, yeah, the bracket just means it's a vector. So the bracket just means like x component, y component. Jeff says, you're measuring the change in f as you move along the edge of the circle. Oh, okay. Okay, so sure. So, grad f, which is like 2x minus 1 comma 4y. I think this is linear algebra that Odin's in. It is. It is like xy. Yeah, exactly. Is equal to lambda grad g, which is lambda, and then this is 2x, 2y, and that's equal to lambda grad g. Okay, so then you match up the components. So this is equal to this. So 2x minus 1 equals lambda 2x. And then 4y is equal to lambda 2y. Cool. All right. And then apparently there's some cases. Oh, and then also this is true, right? X squared plus y squared has to equal to 1. Right? Okay. So apparently we take some cases. We say, what happens if y is not equal to 0? Or can we just like solve this? I feel like we can solve this, right? This is Calc 3. I guess it is. It's multivariable. Fine. Okay. I think we just solved this, right? So from this, let me move that over. So 2x 1 minus lambda is equal to 1. So 1 over 2x. So wait, so lambda. Oh, okay. Let's just solve for lambda. I think we just solve for lambda is what we do, right? Lambda equals 2x minus 1 over 2x. Yeah. And then lambda is also equal to 4y over 2y, which is equal to 2. Wait, so is lambda just always equal to 2 then? Okay, so if lambda equals 2, this is Calc 3. Happy Thursday! What's up, Fembox? Okay, so if lambda equals 2, I mean, then y can just equal whatever the fuck I need it to be, right? As long as y isn't equal to 0. Right? If y equals 0, then this is gone. Then lambda, I think, can be whatever. Thank you, Screen Danger. He says, shouldn't you find x and y and then find lambda by putting it in the g? I don't know, actually, but yes. I kind of like that. Let's do that. So you want me to solve for x and y in terms of lambda, maybe? I like that approach. That to me sounds nicer. Okay, so 2x. So here, let's move this over, and then let's move this over. So I'm going to get 2x minus lambda 2x is equal to 1. So that tells me that x, 2 minus lambda, is equal to 1. So x is equal to 1 over 2 minus lambda. For this one, I don't really get anything for y, right? I just get y can be whatever the fuck, right? Y is unbounded. You're good, Femvox. We fixed it eventually. And then the stream ended up being, like, crazy. I went for 4 hours. The stream's good now, right? I don't think we have any lag. I just had to, like, reset my internet router, which was annoying. So now I know to just reset it before streams. I already have it reset, like, every morning because I have a plant timer on it. But I guess I need to do it, like, right before the stream starts, too. It's great right now. Dubs. Okay, x equals that. Y equals whatever, right? Y equals... I don't give a fuck what it equals. So, Screen Danger, what was this thing about, like, putting it in the g equation? You want me to put it back into this? Is that what you want me to do? X squared plus y squared minus 1 is equal to 0? So what is that? 1 over 2 minus lambda squared plus y squared is equal to 1? Okay. So what does that tell me? I'm just curious. Do I solve for y, maybe? So y is equal to the square root of 1 minus 1 over 2 minus lambda squared. So, in the case of... And then, sorry, what do I say for lambda, though, Screen Danger? Oh, I guess lambda can equal 2, right? Lambda equals 2, this shit, like, blows up. I don't like this, right? What do I do next here, Screen Danger? I'm curious. Why not also solve for... Well, we did solve for y. Y is right here. I couldn't solve for y here because I got that I just got that lambda equals 2. Unless I screwed this up. I don't think I did, right? Why is y backwards? Oh, you're talking about this? This is lambda. That's a different thing. That's a Greek thing. Okay. I don't know where this is going, so I'm going to go back to what I think chat was like trying to tell us. Okay. We can deal with this later if we want to as well. What grade do you learn this? This is upper high school. This is or honestly college. Oh, lambda comes up in high school for sure. Okay, so let's say from this, right? Wow, that's cool, TJ. Lambda is equal to 2. Cool. I'm just going to do that. So then from here, I get 2x minus 1 is equal to 4x. So then x is equal to minus 1/2. So then from this, if I plug this into the constraint, right, x squared plus y squared is equal to 1. Now I get that 1/4 plus y squared is equal to 1. So y is equal to the square root of 3 over 2. Cool. Or plus or minus the square root of 3 over 2, I guess, yeah. Oh, and then we look at what the value of the function is. So f of negative 1/2 plus or minus the square root of 3 over 2. So that's kind of annoying, right? Because f was this kind of ugly-ass function. Yeah, there you go, screen danger. Yeah, and then you substituted it, yeah. No, this isn't that bad. You can figure it out. Okay. So if we plug this in, right, you get 1/4 plus 2. Again, I don't care if it's plus or minus, right? So that's going to be 2 times 3/4 plus 1/2. So it's 3/2 plus 1/2, which is 2. So 2 1/4, right? So that's equal to what, 9/4? Nice, cool. So we already have some sort of point, right? This was equal to 9 over 4, I guess, right? And then I think we have to consider another case of what happens if y equals 0, right? Because if y equals 0, this goes away, then this goes away, and then I get that x is equal to 1/2. Oh, very cool. Okay, so then we can say, like, if y equals 0, then x is equal to 1/2. And so then from solving from this, you get f of x comma y. So f of 1/2 comma 0 is equal to 1/4 minus 1/2. Is that right? Yeah, 1/4 minus 1/2. Or did we do this right? No. Wait. If y equals 0, x squared equals 1. Oh. It is a messy question. Yeah. Okay, here we go. This is solved, right? If y is equal to 0, then x is equal to plus or minus 1. Okay, sorry. If y equals 0, x is equal to plus or minus 1. We had a condition where y couldn't be equal to 0? I don't think we did. From here? Is this maybe from what we said that y couldn't be equal to 0? Because then lambda is unbounded. Anyways, plus or minus 1, comma 0, then gets you 1 minus 1, or 1 plus 1, right? So you either get 0 or 2. Ah, but this is greater than 2. Yes, dude, you're right. Okay. So this is the max. Okay, so we say max at, what was it? This. And then we say minimum at, f of 1, comma 0 is equal to 0. Cool. And then you're done. Nice. Good question there. Very interesting one. I haven't done Lagrange multipliers in a while. Thank you, chat, for helping me out to do that one. What program do you use to take the notes? I use Group World. They're kind of an old school website. They've been around for forever. I've used them just with groupworld.net. Yeah, this is them. Dude, look how old school their fucking website is. But it is, I will say, it is very powerful. It's very basic. It just works. I've probably been using it for like 10 plus years, and it's just rock solid. I've never had a problem with it, so I just use it. I started using it when I was online tutoring back in like 2014. Oh, you're also teaching online? Yeah, check that one. It's great. I use it all the time. I have thousands of hours logged on it probably. Okay, sick. So let's look at what the Q's at. So H, Odin root, we got yours done. Oh, no, sorry, wrong one. Let's clear that. That means next up is flex lore. What do you got me for your flex lore? Prove with resolution. Wait, what the hell is this? What is this? What is it? What logic is this? Prove that not Q implies not P, and then I don't know what this thing is. Is that P implies Q? Isn't this just called the contrapositive? Is this the contrapositive? I feel like it is. Dear, that is that's a difference of cubes. Oh, entails. I just remember from the times I've taught logic, right? That this one and this one are true. Like these are equivalent statements. This is equivalent to this. And that these two are equivalent to these, right? I mean, I could prove it with a truth table, right? And maybe this is the wrong way to think about it, but whatever. Bottom line should say by. What is it by? What do you mean by BI? I don't know. For oh, biconditional. Oh yeah, this says yeah, right. This is wrong. This is biconditional. Resolutions, not truth tables. What are resolutions? I have no clue what a resolution is. List of logic symbols won't help. Yeah. Well, I'm gonna do it my way. Okay. PQ. And what is this, like? P implies Q? What is this, like? If this is true, this is true, this is true. If this is true, and this is true, that's false. If this is true, and this is true, this is true. And this is true, this is true. This is also true, right? I messed up the second and the third. Oh, I did. Sorry. Sorry. Yeah, flipsies. Flipsies. Yeah, sorry. Yes, if this is true and this is false, then P implies Q is wrong. Correct. Yes, thank you. If P is true, then Q has to be true. So if P is true and Q isn't, then P implies Q is false. And then if P is false, Q can be whatever for P implies Q, right? So then if we look at not Q, and what is this, like not P? And then it's, what is it? Not Q implies not P. Okay, so if P is true, this is false. If P is false, this is true. If P is true, this is false. If P is false, this is true. This is true, this is false. If this is true, this is false. True, true. And then let's think about, oh, so actually I want to switch the order of these. Fuck, 1 sec. 1 sec, sorry. Wait. No. P implies Q. Oh, not Q implies not P. Sorry, I fucked that up. There you go. Okay, now it's actually true. Okay, good. So 0 implies 0. That's true. 0 implies 1. That can also be true. 1 implies 0. That's false. 1 implies 1. That is true. And then I think what you show is that, look, this truth table is the exact same results as this truth table. Thus, they entail each other, no? Yeah, I'm just going to say it works. I don't know what resolutions are. But this is one way to logically prove that it works.
Well done!
Resolution. Yeah, symbolic logic. Yeah, that's cool. I mean, I can see. What is this? Yeah. No, not doing this. Nope, sorry. That looks like fucking Chinese to me. And I don't speak Mandarin. But it's okay. I don't know everything. Far from everything. That was Flex Lore. It's discrete math. Yeah, it is for computer science, for sure. You know, I'm actually teaching a student at UCLA, like I'm tutoring a student who's a philosophy major, and they have to take logic, a pretty intense logic class, because, you know, logic is involved with philosophy, I guess, or something. It's really fun, though. I've been learning a lot. If you want to see, like, the types of problems I've been doing, they're actually pretty cool. Yeah, UCLA. Yeah. So I've been doing stuff like this. Look, like, this was an example of one. Wait, here's the question. Yeah, like, design x plus y from 0 to 15 that's binary. And then, like, you have to define what, like, a full adder box is. And then you have to, like, do this. This is what a 4-bit adder would be. This is, like, this type of function. This is for a philosophy class at UCLA. I'm helping tutor a student. This is logic. I think it's, like, computer science. No, but philosophy kids have to take this. Yeah. It's pretty funny. Yeah, it's like circuits. Yeah, pretty fun. Anyways. Yeah, I mean this student obviously needs a lot of help because she's a humanities major. So, like, she's like, what the fuck did I get myself involved with here? I'm like, yeah. But it's really cool. I like it. It is definitely more like computer science stuff. Yeah, a full adder and a full subtractor. Yeah, sick. Yeah, like the carries and the sums and stuff. Yeah, all that stuff is super cool. Okay, so someone's asking about shear stress. Oh, King Domo. Okay, I'm gonna punt on this temporarily just because that's an engineering thing. I can't be on for 3 hours today or 4 hours like last time because I do have to go in about 40 minutes. But Bing Bong, I will do yours. Oh, you're doing Cog Sci at UCLA. Sick. I did my PhD at UCLA, and then I also taught physics at UCLA. So Are you by Franz Hall? You know the inverted fountain? If you touch it, you have to stay an extra year. They have this fountain at UCLA. It's called like the inverted fountain. It looks like a Sarlacc or something. And like you have to touch it right before you start going to UCLA, and then you're not allowed to touch it again until after you graduate. Otherwise, it's bad luck and you have to stay for an extra year. Yeah, okay, cool. The following limit represents the derivative of some function f at a, state f and a. Okay, cool. This is great. You've only taken 2 math classes. Wow. All right. So, the limit definition of a derivative. There's a couple definitions. This looks like f prime of a is equal to the limit as x approaches a of f of... how does this work again? I think it's f of x minus f of a over x minus a. I don't like this one. I like doing... Here, I'll show you the one I like. Yeah. How do you get better at math? You feel so dumb? Just watch the stream. If things don't make sense, you know, like, ask a question. I'm happy to explain things. Yeah. Also, you can watch my YouTube shorts if you want. I also have them on TikTok. Sorry, I'll show, I do have them on TikTok. One sec. Let me pull up TikTok. So this is my, because I know a lot of you guys are on TikTok. If you go watch my page here, I have a bunch of these fun little, like, videos on different topics. And I think I did one on, like, derivatives. Where did I do it? Completing the square? No. Limit definition of a derivative. Where is it? Where is it? I totally did it. I did it because I was applying for a job and they required me to do a video for it. Sig figs. No. Mean value theorem. No. Community guidelines violation. Was this the one? Oh, it might have gotten taken down for I think I did one where I put what's that scary creature that everyone hates? Like Moo Moo? Oh, here we go. How to understand the limit definition of a derivative. Yes. Thank you, Bing Bong. So here. I talk about... This is the definition I like. I like this definition a lot better. But then in this video, I kind of show, like, where it comes from. And it's really just finding the slope, or, like, the secant line between 2 points. And then you're taking the limit as the distance between those 2 points just gets closer and closer to each other. So there's like x plus h. There's fun, like, there's like sounds and memes and stuff. So yeah, this is a great example. I have this video if you want to learn about the limit definition of a derivative and like what it means and how it works. This kind of shows how as you have your 2 points and you start bringing this point B closer and closer to it, that the limit definition of a derivative, which is just the slope, which is y2 minus y1 over x2 minus x1, you can eventually get to what's called like the instantaneous slope. So here, it'll do it. And that's that line. Instant rate of change. And the way to get that is to just move this like closer to it. There you go. Look, it gets closer, it gets closer, it gets closer. Now it gets closer, and then you have it. Anyways, so yeah, if you're wondering about math and stuff and you want to learn, go check that out. No, the other, yeah. In the essence of time, Bing Bong, I'm gonna ask you to just go watch my video on it, so that it makes sense for you. But I'll do this one for you. But then go watch my video, and also again, if I was able to stream 4 hours today, I would totally do it. But I have to cut the stream in like 45 minutes, and there's quite a queue. How can something change instantly? Yeah, I know. It's just like at that instant. Anyways, looking here. All you're trying to do here, Bing Bong. Got you, thanks. Yeah, cool. Can you explain quickly limit x equals 1, x2 minus 1, x minus 1? Random content. Can you, like, find a screenshot of that and just submit it? Submit it. There's a website down there. So, I can't really read the text to, like, figure out what the limit stuff is. So, f of x is this part, right? So, that tells me right away, if this is tan x and this is f of x, that tells me that f of x is equal to tangent of x, right? And then x approaches a. That tells me that A is equal to pi over 4. So you're kind of done. This is like easy mode. This is really dumb. But you could also see why this happens, right? So this is f of A. So that would be f of pi over 4, which is equal to the tangent at pi over 4. And the tangent of pi over 4 is equal to 1. So that's why that's 1. Yeah, you're just matching it with this is all you're doing. It's really silly. As to, like, what this is, I don't think you can solve this. Usually you use this limit definition because there's something fun algebraically you can do with it to, like, cancel things out. You love the sound effects? Nice.
That's dope.
Wait, what is tangent sine over cosine? It is, for sure. It is sine over cosine. Yeah, I don't know if there's a way to evaluate this limit. Anybody in the chat want to tell me? L'Hopital's rule? Oh, you're right. Thank you. But they don't learn L'Hopital's rule this early on. Right? L'Hopital's is like at the end of the year. Yeah, okay. But yeah, just for shits and giggles, let's show how you would solve it. So this is like, spoiler alert, Bing Bong, this is how you solve it using a thing called L'Hopital's rule that you'll learn later. Yeah, it's okay. So whenever you're evaluating limits, what you want to do is you want to try to, like, just put this thing in for x and see what you get. So I would get tangent of pi over 4 minus 1 over pi over 4 minus 1. Tangent of pi over 4 is 1, so you get 1 minus 1, which is 0. I'm sorry, this isn't over. I'm sorry, minus pi over 4. And then this part is also 0. Okay. When this happens, this is a condition for you to use what's called L'Hopital's rule, or as I call it, the hospital rule. Okay. And what L'Hopital says is that you just take the derivative of the top and you divide it by the derivative of the bottom. And you see what that turns into. And if that's something that's not 0 over 0, then that's also what the limit is equal to. So when you just try to plug it in and you get 0 over 0, that's like green means go, to take the derivative of the top, take the derivative of the bottom, and then plug it back in again and see what you get. That's... this is the definition of tangent of x. I don't know, let's just see if it works. I'm just curious. So, derivative of tangent of x is secant squared of x. So you get secant squared of x minus the minus 1. Derivative of 1 is 0. Cool. All over this derivative. Derivative of x is just 1. And then pi over 4 is 0. Okay, so now this is great. Yeah, so now we have the limit as x approaches pi over 4 of this. So here's what we did. We did ddx of tangent of x minus 1 over ddx of x minus pi over 4. And when you take derivatives, tangent turns to secant squared, x just turns to 1. Plugging in now pi over 4, you're going to get 1 over the square root of 2 over 2, right? Which is just equal to 2 over the square root of 2, which is square root of 2. Well, it's just square root of 2, right? Square root of 2. No. Yeah, it's just square root of 2. Yeah, done. Oh, squared. Fuck. Okay, sorry. Squared. 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 Okay, the answer is 2. Nice. Can you go over the properties of trig and calc? Like, yeah, you would need to know those. Yeah, I mean, that's just a list you have to memorize. So, these. Yeah, you just need to know these. Indeterminate form, 0 over 0, correct. Okay, cool. All right, nice. You're my goat. Dope, dude. Okay, I'm gonna put this solution in the Discord for you. Bing bong, bing bong. Yo, tell Joe Biden what's up. Take me to dinner. Best prof ever. Thanks, bro. Okay, so this is Bing Bong. Office hours. Bing Bong. Dude, you know what? I need to get that as I have like a lot of like fun like things here.
Damn, man, look at that. Look.
Oh, you can't see it on TikTok. But if on YouTube, on Twitch, I have a bunch of like funny videos that I can like cue on things. I should get the Bing Bong one. Yeah, actually I'm gonna write that down, sorry. Get the Bing Bong sound effect. It's pretty fucking funny. Okay, let's see. Can you do it right now? No, in the interest of time, no. All right, so I'm gonna mark done. Bing Bong, can I go over the second half? Can I come back to you, Bing Bong, and do the second half question? Let me help out Suspicious real quick. Wait, what? Oh, is this? Wait. Oh, this is kind of cool. Something with a squirrel. It's okay, cool. Yeah. Also, yeah, we stream 5 times a week. So, again, website has our calendar on it here. Just click there, and you can see, like, all the days we stream. Yeah, you're welcome, dude. Okay, dude, what the fuck is this, dude? Yeah. You're gonna see me a lot? I hope I do. If you join our Discord, by the way, we give out gift cards to students who ask questions and like do stuff. So if you want to get like credit for like participating here, join the Discord as well, and then just DM me, be like, yo, I'm Bing Bong. I do chem. I definitely do chem. Yeah, I do a lot of chem. Femvox, yeah, I'm talking about the you know, the videos I have sometimes, like the effects on here, because TikTok requires me to stream on a second streaming PC. I can't pipe the OBS effects onto the TikTok stream. TikTok's weird. They just will not give out, what's it called? RTFM keys? No, let's read the fucking sorry. RTMP. They won't give out RTMP keys. They're very protective about their stuff. Yeah, hell yeah, dude. All right, let's do it. All right, a cannon is located 8.01 meters above a safety net. I'm just going to say this is 8 because what? I'm just going to call it 8. If your teacher is mad about 0.01, they chose violence this morning. It's above a safety net on Earth, aimed 65 degrees relative to horizontal. Dude, what's with these safety nets? Exactly. Clickbait's also right. You can also submit your questions to the Homework Help text channel, and some of us can help you if you can't make office hours. Exactly.
Good job.
Clickbait's a very, like, smart person who's in, like, I want to say grad school, or, like, definitely upper college. And so, and Clickbait, you've written some awesome solutions before for other students. So, 100%. Even if I'm not streaming, I'm not the only person that helps. I'm not the only person that does this. We have a lot of other awesome community members in the Discord that can help you out. So, another reason to join Discord. Okay, 8 meters, 65 degrees relative. It's funny how it's also 65. We literally did another question where it was 65 degrees. Oh, you're okay, WW. Oh, okay. If X is equal to 20, how big a safety net is needed? Okay, what's the required value of X for the city? Indefinitely? Wait, how did you generate this, W, dude? Dude, how did you generate this? Dude, I'm really curious. Is this ChatGPT? It looks too funny. Dude, yeah, dude. What's the required value of X for the scroll to remain in orbit indefinitely? That's another funny one. Yeah, I googled like newspaper clipping generator. That's so cool though. It's not the worst thing in the world though. Clickbait's giving me like 1D potential wells. Okay. I feel like I kind of want to do some of this, though. And then clickbait. We'll do quantum mechanics. And then was it dude? Or let me... Okay, let me do this one real quick from dude. Just because it seems more normal. And then we'll do the other two. Because they are fun. In a bag containing A1 red balls and B1 blue balls, make a formula that outputs the chance of selecting exactly A red balls and B blue balls out of the bag. Each ball is selected one at a time. Oh. What does this even mean? Sorry. I'm assuming this is A1, B1. Make a formula that outputs the chance of selecting exactly... Based on what? On, like... Is it as a function of how many balls you pull out? I feel like there's something missing in this question. Dun, 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 dun. I can definitely do. Yeah, if you here, Clippy or Subby, send me a chain rule question. I'll do it. Presumably, out of A plus B balls, it's on A and B. Oh, okay. Oh, okay. Oh. You want P of A and B. Got you. Okay. I got you. Okay. Yeah, so this is a function. Interesting. Well, let me just do some I always like to do like some example numbers so I can just like kind of see what happens. Let's say it was 1, 2. So let's say I want to select 1 red ball and two blue balls. 2 blue balls. Okay. The probability of selecting 1 red ball, exactly 1 red ball, right? So you would have 1 over A1, right? Wait, no. You would have A1 over A1 plus B1, right? Times getting the blue ball, which is B1, and this is like A1 plus B1 minus 1? A1 plus B1. All my chooses are upside down. But that reduces because after you've chosen A balls, the rest are blue. Right, I think it would be... And then this is like B1 minus 1 over A1 plus B1 plus 2. Or minus 2. This would be the equation, right? A1 plus B1 minus 1, right? Because you have 1 less ball to pick from. But then also, I could pick... Right? I mean, this is one way for it to happen. But then you could also have plus B1 over A1 plus B1 plus B1 minus 1 over A1 plus B1 minus 1 plus A1 over A1 plus B1 minus 2, right? Yeah, I'm just doing it for 1 and 2. This is not the same as this. Oh, fuck. Bro, this sucks, dude. What? Wait, how do you do this? This is a tricky probability question. Because I have to do all the permutations, right? It's like red, blue, 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 red, and then I think I have to do like blue, red, blue. Jeff says, in general, once you've chosen A red balls, you're done. The remaining A plus B1 minus A must be blue. Okay, I like this. I kind of like what he's saying here. Okay. But isn't there like a bunch of different ways you could do that? So that's like A1 choose A. Right? These are all the different ways you can choose A balls, right? You can choose A balls out of A1. And then the remaining A1 plus B1 minus A must be blue. The idea is kind of right, yeah. But then there's also the permutations of it, right? Because you can start like picking reds and then picking blues. Oh, okay. Here, I'm gonna lean a little bit on chat here. It does have 4 inputs. Yes, I get it. Get rid of the choose gets rid of the permutation. Okay, cool. This is what I'm given, just in the interest of time, and then I just want to like try to understand it. A lot of probability stuff is kind of hard to just like mechanically come up with. You have to kind of have some fun intuition on it. So let's see. So this, I agree, is the amount of ways to choose A balls from A1 times the amount of ways to choose B balls from B1. And then, okay, so then you're dividing that by the total, like, number of things in the space, in the probability space, which is the amount of ways to choose A plus B balls away from a total of A1 plus B1 balls. Okay. I think I get it. I definitely get this part. It's interesting how this probability multiplies by this one. I mean, I understand this. A1 choose A over A1 plus B1 choose A plus B. I totally get this. That's the probability of picking A balls. Because, yes, yeah. Okay. Well, oh wait, the A plus B part though, wait. Yeah. And then I guess you multiply it by the B1. No. Okay. Alright. Real quick, because I'm running out of time, I want to make sure I get through all the students. I mean, this is a cool question. I don't know exactly if I can explain it the best, but that's what it is. Alright, cool. Nice. That was dude. I feel like, dude, probability questions like that are always kind of like aha moments to me, where I don't think I would get it on its own, but then once I see the solution, I'm like, yeah, duh. But on its own, it's like quite tricky to get. I think, what's the A1 and the B1 doing in there? It's like, oh, A1 and B1 is how many total red balls and how many total blue balls there are. That's what it was. Yeah. So, the bag contained A1 total red balls. Oh, you got it? Cool. Okay, yeah, awesome. This isn't stats. That's probability. Oh, wait, someone gave me a super rough one, dude. What? This is like the Pain Olympics for, like, the chain rule, dude. What? Subby. What are you doing to me, Subby? What the fuck? No. No, don't do this to me. Oh, Christ. Econometrics? Not really. What's econometrics? Is that like supply and demand? Femvox says the answer is 0. Is it? Oh, it is. Yo, this is hilarious, dude. Yeah. Subby, this is kind of a troll question. I think you just Googled something here. But, okay. This right here and this right here are the same thing. So you have basically like sine squared of u plus cosine squared of u, where u is equal to x tangent squared x cubed. Right? But then sine squared plus cosine squared is 1. And d dx of 1 is equal to 0. Yeah. Here, let me maybe show how you would do the chain rule of just like part of this. Okay? Let's just do this, because I feel like this was maybe like... I know what you did. You tried to look up a question, but they kind of gave you like a troll question. Okay. Let's say this is your function, and I'll show you how to do the chain rule of this. It's a 3-function chain rule that gets really easy once you just realize that sine squared plus cosine squared is equal to 1. And that's why trig is great. Trig will always help you out. Okay, f of x is equal to this. Okay. Right away, this looks like a product rule, because I have something that's a function of x multiplied by something else that's a function of x. No, you're okay, Subby. It's okay. Here, let me do this. Yeah, it's kind of a funny troll question they gave. But I'll explain this part, because this isn't a troll question. So this is a product rule. And so when you have the derivative of a times b, that's the same thing as a prime b plus b prime a. Okay? So I know here I'm going to have this prime times this plus b prime a. Okay? That's how I like to kind of like think about it. So like the biggest big picture thing of what's happening here is a product rule. And this is easy, right? Because the derivative of x, that's just 1. And then this would be times tangents. Well, here, let's like write it down a little bit further. Like what happens. Fuck. One second. So this is equal to, right, because this is the derivative of x. And then this is tangent squared x cubed. I should have copied this. Okay. Derivative of this is just 1. So you have 1 times the thing all by itself. Cool. Plus, this is the hard part. I gotta take the derivative of tangent squared x cubed. All right, so we're gonna do a little like little side quest here, Subby. So I'm gonna say, what is d dx of tangent squared x cubed? All right. The way I like to think about this. So first of all, these exponents here on trig functions kind of mess you up when you think about power rules and stuff. So instead of saying tangent squared of x cubed, I'm going to say the tangent of x cubed squared. That's the same thing. Why this is easier is because now I don't know what the derivative of tangent of x cubed is, especially not tangent of x cubed squared. But I do know what the derivative of something squared is, right? That we know is going to be equal to just like pulling the 2 down here, making this a 1. And then the last thing we have to do, though, is we have to multiply it by d dx of whatever's in the square. This is the chain rule. So far, what's happening? Okay. So the derivative of something squared is the same thing as 2 times that something to the first. But then because we did this trick of calling whatever here was like a pink square, I still need to multiply by the derivative of what the pink square is. Okay. So now let's look at this. I can definitely do stoichiometry, Chloe. Let's take the derivative of tangent to the x cubed. Okay. Again, I don't know what derivative of tangent of x cubed is, but I do know what the derivative of tangent of something is. Okay? That's equal to secant squared of whatever that something is. But now, because we borrowed simplifying whatever was inside, we still have to do d dx of the square again. Okay? And now this is easy, because ddx of x cubed is just 3x squared. So the last step here is to like put everything back together, okay? So this is now 3x squared. Okay, so we have 3x squared secant squared of x cubed. And then that was all times this. So that was this to the first, and then that was all times 2. So now you get, right? So ddx of tangent squared x cubed is equal to this. So it was 2 times the tangent of x cubed to the first times the derivative of tangent, which was secant squared of x cubed, times the derivative of 3x squared, which was times the derivative of x cubed, which is 3x squared. So that's the whole thing there. So then that would go into here. And so you can simplify this a little bit. So this is 6x squared tangent x cubed secant squared x cubed, and then times x. So times x, this becomes x to the third. And then you're done. So that would be the answer for that. Does that kind of show how you do like the product rule and then the chain rule? Yes? Okay, nice, dude. Yeah, awesome, great. I'll put the screenshot of this in the server if you want to see it, subby. If you want to join our Discord, the link's the same place that you submitted the screenshot. There's a link there for it. Sorry, I'll put it in for you guys. So yeah, Chloe, I can definitely do stoichiometry if you want. I did have some questions from one side. Clickbait had a fun one. He wants me to do quantum mechanics. Clickbait's always trying to get me to do quantum mechanics. Alright, let's see. Dun, 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 dun. Okay, let's see. I will work on this for 10 minutes, and then I gotta go. So, probably last question of the day. Consider a particle an infinite square while the particle is in the state of that. Cool. It's a superposition of states. Calculate x bar and p bar. Okay. I believe x average, so this is average position. Is that this? I think that's the way to write that, right? Oh, good lord. Oh, good heavens.
You done messed up, Aaron!
Okay. My questions are like 100 grams of blank. Oh, yeah, is equal to whatever. Yeah, you can do that, yeah. Okay, this is called Broncat notation. The other way to write this is the integral. Is it from negative infinity to infinity? Clickbait. I'll check your answer here in a second. I'm actually curious about it. And then that's going to be 1 over the square root of 2 phi 1 e to the, so star means it's the complex conjugate, so that's e1t over h bar plus phi 2 e to the minus e2 t over h bar. That's where you are now. Yeah. Okay, cool. So that's sorry. This is also positive I, right? And then this is all being sandwiched with an x, and then sandwiched with the other thing, right? But then these are negative, and then this is dx. Mars says, isn't the direction of the displacement changing? Yeah. No. But my question with that one, Mars, was displacement is... I didn't know what the 2 time points are. So if they're talking about, like, the beginning and the end, the displacement is 0, because it bounces up to the same position. Am I supposed to know this in Chem 11? Oh, mass to particles, yes. This, no. This is quantum mechanics. You're not supposed to know this. Okay. I think the cool thing here, though, right? Because, I mean, this looks like it should be, like, some foiling. But correct me if I'm wrong, clickbait. I feel like phi 1, phi 2 is equal to 0, right? Like, if you do the cross terms, I'm pretty sure the eigenstates are orthogonal. So, only phi 1, phi 2 survives. Sorry, only phi 1, phi 1 survives, only phi 2 survives. I think. Let's see where you're at. Also, wait, why are there signs on this stuff now? What? Wait 1 sec. You assumed you know how to integrate? Okay, cool. I don't know why I can't copy your image in, though. Come on. Okay, here we go. Okay, cool. So we agree with this. Right? I agree doing this. I agree with this. Okay, cool. Why the sun? Oh, okay. You assume that phi 1 is this type of wave function. Okay. Ooh. Yeah. Ugh. I want to say that phi 1, phi 2 is orthogonal. I'm asking chat. Chat can do like this is baby quantum. Not this, sorry. Okay. Boom. Okay, I'm gonna say solve this. Can we assume the eigenstates are orthogonal? I think they are. I think the eigenstates are orthogonal in the 1D potential well. Some of the stuff I know how to do off the top of my head. Some of the stuff I need help. Boom, boom, boom. There's an oscillating interference term. Oh, due to E2 minus E1? Oh, shit. Yeah, because it's a superposition of states, which is interesting. First, I find the product of wave functions. This leads to a general form for the interference. What's an eigenstate? Cool. I can explain that. I mean, that's not too hard. So, if you end up having, like, what is it? A lambda equals... Wait, this is like a matrix, right? Or it's like this. A lambda equals... no, wait, now I'm messing up. Yeah, it's like lambda b or something, right? Like b lambda? Because the classic one is this, like h psi equals e psi. I believe this is the eigenstate, eigenvalue. Well, this is eigenvalues. Oh, and then the eigenvectors. Oh, man. Yes, no. This is like the operator, which is usually like some sort of matrix. These right here are the eigenvalues. And then this right here is the eigenvector, which is kind of like an eigenstate. The wave function is the eigenstate. Yeah, it's like the steady state solution of like what fits the equation. Eigenvectors are those transformation in a multiple of the original vector, correct? Oh god, it just... Dude, it fucked up. Dude, fix the latex. For the love of Christ, chat. Just fix the latex. Intermediate value theorem. I can. I do have to end the stream in like 3 or 4 minutes, unfortunately. I have a video. Eric, if you go to my TikTok, I have a really fun video on it. If you want to check it out. Where is it? Here we go. Understanding the intermediate value theorem. Go check this video out. It's fun. Yeah. I went over it yesterday, actually. Someone was asking me about a question. And then if you want to come by the stream the next time we're on and you have a question specifically around it, I can show you like how it works. Okay, let's see here. So this was very similar to what you wrote, right? These are the eigenstates. That's the eigen energy values. Okay, exactly. And then this is what I came up with, right? 1/2, 1-on-1, 2-on-2, and then, oh, e to the I omega t. Interesting. Yes, where omega is the difference in the energies. Yeah? Oh, this is so cool. I'm starting to get like kind of taken back to this. Okay, so what happens, right, is that when you multiply this one with this one, right, you end up just getting phi 1 e to the 0, right? And this is also 1 over the square root of 2. So this ends up getting you 1/2 phi 1 squared x, right? Because this will cancel with this, and then you get plus 1/2 phi 2 squared x, and then you get cross terms. So you get 1/2, which is then, what was that? 1/2 phi 1 phi 2, but then this is e to the I t over h bar, and then it's e1 minus e2, right? And then I think what they do is they call this thing omega. Or they call it e2, right? Okay, so it's negative for the 1, 2, because then that's e1 minus e2. And then it's positive for the 2, 1. Okay. So then... okay, cool. Right, for each of the stationary states... Oh, this is very cool. Because, clickbait, right? The probability of this is 1. Right? This is equal to 1. The probability of any state on its own, right? This is also 1. This is interesting. I think that's where you take into account this sign fun stuff here. And then this is E. And so that somehow becomes that. Hence, x of t is equal to that. Oh, okay, cool. Where... oh, wow. And then that's what omega is. Okay, this is very cool. Here, I'm going to share this with you just because I have to go. I have to go teach another student. I would love to, like, work this question out more with you. But unfortunately, I have to go. But I am... thank you for asking a question that's, like, a little bit more approachable in terms of quantum mechanics, because I feel like I can't solve this one. Anyways. Okay. Oh, River, I just saw you. I have to end the stream. Okay. Thanks, everyone. Thanks, everyone, for coming to Actual Education Office Hours. Appreciate all the questions.
That's dope.
Our next stream is going to be on Monday. I'm at TwitchCon this weekend, so no stream on Sunday. If you want to ever see when we're streaming again, go to that website, actualofficehours.com, and you can click here on streaming schedule, and that's an awesome way you can see when we are streaming and when all our other friends are streaming. Zach's streaming on Saturday. Big shout out to Zach. To e to the 2i pi. Yeah. So there's Zach. Make sure to... what's the web link? www.actualofficehours.com. That's what it is. Yeah, there's the schedule. So, thank you, Fembox. I will. If anybody else from Twitch is going to be at TwitchCon, please come say hi to me. I'll be wearing a big gold jacket. You can't miss me. All right. If you're watching us on Twitch, we're gonna go raid somebody. Let's see who's online on this fine Thursday. Prof, Astra Canuck, High Potential, Rondabot. Dude, why is High Potential sleeping? It's early. Blah, 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 blah. Picking up the boy. Thanks for lurking. Oh, he's out. Okay, go say hi to Astra Canuck. Cool. All right, we're gonna raid. Sick. All right. Enjoy the rest of your week. I hope you guys have an awesome weekend. We will see you on Monday. Peace.